In my last video, I made mention of the circle and we're able to establish some formulas that we use to form some properties of a circle. Now, I want to say a few things again before we go into calculation of some properties of a circle. Like I said, this is a circle, and I told you in last class that the length around the circle is called the circumference. Now, before I go to those formulas that was established that day, remember that any line I drawn from this part to meet from one part of the circumference to another is called a chord. It's called a chord. If it passes through the center, we call it diameter. But it's also a chord. But it's a special type of chord because it passes through the center of the circle. So we don't call it a chord, we call it diameter, but it's also a chord. Now, the chord is performing two functions in a circle. Number one, it divides the circle into two arcs. This line is called the arc. This is the minor arc. And even this other side is also called an arc too, but this one is what? Major arc. Number two, it divides the circle into two segments. The inside, this inside, this place is called the minor segment, and this other one is called the major segment. But the line is called the arc, the minor arc, major arc. But in the last class, we were able to establish some formula to find some properties about the circle. Number one, we talked about the circumference. Circumference C says what? 2 pi r. We're told how we're able to get this formula. And number two is the area of a sector, or area of a circle first, area of a circle. The whole area is what? Pi r squared. Number three is the length of an arc. Length of an arc, which is theta over 360, theta over 360 times 2 pi r. Number four is the area of a sector. Which is theta over 360 times pi r squared. Number five is the perimeter of a sector, which is which is radius plus L, which we write as 2 radius plus theta over 360 times 2 pi r, because this our L is the length of the arc. Remember, if I trade this one back to center, this one back to center, this radius, the whole of this portion is called a sector. This line alone is called the arc, called the length of an arc. So in this class today, we want to talk about the length of this arc. The area can easily be, circumference is also called the perimeter. It can easily be found, just multiply 2. Usually our pi is equal to 22 over 6, is a constant, or 3.142. These are the two values of pi. Now I want to look at the length of an arc as I clean this. Now, the length of an arc. Length of an arc. Let me draw this again for us to have a better understanding of what the arc stands for. Angle at the center is 360, but we can carve this one out as theta. Then from here to here is the length of the arc. If I pull it out, I can have it this way. This is the theta here, radius, radius. So that when you see it outside, you know it's a sector. So the whole of this shape is called a sector, but this line from here to here is called the length of an arc. So therefore, we said that length of an arc L is equal to theta over 360 times 2 pi r. Now, from here now, we want to take examples. But before we go to the example, remember also that this length of an arc is the minor arc. This other one is the major arc. You can be asked to find the length of the major arc. Don't forget that this other side will become what? 360 minus theta. In case you ask to find the length of the major arc. This is the minor arc. So it depends on how the question is given to you. So, I don't want this video to be too long. In our next class now, we're going to take examples of how to find the length of an arc.